to understand how to recognize tools today. We're going to look at different tool styles. Maybe you've never played with tools. You won't be the first and you won't be the last student I've ever had that's never really worked with tools. Okay? Students understand how to maintain proper tool control and accountability, and students should know how to use the right tool to do the right job. Okay? That's why we do not like hammers and we don't like disposable wrenches. Okay? All right. Chapter 11 is where we're going to be at. If you're reading in the book, I have a few pages for you tonight, but specifically focusing on chapter 11. Okay? You don't need it at this time. We're actually not going to spend a whole lot of time in here just right off the bat. Get you up, get your brain flowing because you're all like Tuesday brain right now. All right, so maths and pros, final and midterm calculate to be 40%. You will have both in this class. You'll have various quizzes. If you don't do well on a quiz, it's okay. It's 20% of your grade, and there will be several quizzes for you to hopefully catch up. 40% of your grade is your labs. If you're late, that is not my problem. I am a parent. I'm just not your parent. Okay? So I will not chase you a lot on the lab. If I do chase you, it's because I'm tired of the box telling me you haven't accomplished your task. You haven't accomplished your task. Okay? It's more of a selfish reason that I really want to get all the little boxes green. Yes.
I got a notification from Miss Christina's class that ended yesterday, physics, saying that I was past due on a lab. So I went to check the lab and I had turned it in already. And it said graded, it was graded. But the email is saying past due. And I think actually right next to graded, it also said past due. So you know what's up with that?
It just, oftentimes it'll depend on whatever setting she had for the end date for that lab. Okay, so the Moodle settings are really not my problem. Okay, Nick just take care of that. Yeah, or you can ask me first, kindly. Ask me. Hey, could you explain why I said that? Okay. If it's more than a week past the end of the class, the highest grade you get is 7. Okay, that sounds brutal, but I've had students abuse that in the past, and that's why we kind of pushed. Because I think I had to chase one student for 4 months last year to get a lab done, and it's like, wait a second, you're here to be educated. We shouldn't have to chase you. So get it done so we can move on. Okay. So 70 is required. 70 is required on the final and each test to pass each class. Okay. What's the final going to be like? Mostly FAA, but you'll also have to use a micrometer during class. I'm going to give you bolts. You have to read them correctly. One of the most, I won't say dumbest. What's a better word? What's a better word than dumb? Frustrating portions of the orals or practicals to fail is like you get the job done. So say I'm doing power plant orals and practicals or practical, and I shove the cylinder on. I put the cylinder on, per the manual, and you go to torque it. And Continental gives you 2 different sizes on the engine. Okay, this one did it. But all the new Continentals you'll have one, like the main studs over here are large and the middle ones are all small. So if you're going to use the same torque, guess what? You're going to over torque the little one. And so they get in there and the DME is watching you and you over torque or you torque based on the socket size instead of the bolt size. You fail automatically. So it's like, something so simple that you should be able to pass. Okay, so sometimes during a class you should be able to measure the bolt head so you can torque the correct size. All right. Basic hand tools. How many of you have not done a lot with tools? Okay, a few of you. All right, not a problem. Okay, hammers and mallets, so sized by the weight of the head, different face material, that oftentimes are pretty significantly hard. Let me go through the syllabus real quick, make sure you have any questions before I get into identification tools. Go to the scope here. Scope. Okay, so the first thing on the scope is identification and installation of aircraft hardware. Give me some types of hardware. Mr. Multi, what type of hardware do we have on? You can't take the same bolt. You gotta give me something else. Okay, great. Nuts. Give me a type of nut.
An AN.
Oh, give me an AN nut. You can, okay.
AN.
Great. All right. Give me another one. Somebody else. Give me some other type.
Castellated nut.
Castellated nut. A lock nut. We have fiber lock nuts. We have steel lock nuts. Where do we not use a fiber lock nut, Randall? What? Maybe on something that's hot. You use fiber on exhaust, it becomes unfibered, okay? Unfibered. So little things like that, as you're looking, as you begin to work, it's like, oh man, I've got a fiber lock nut, slap that on to hold the exhaust clamp, and the exhaust clamp comes loose in a matter of what? 30 minutes. Tax it out, add it to it, it comes loose, okay? All right, so identification, installation of aircraft hardware. Will you memorize all the numbers? No, I mean, eventually you will. You know, you'll say, oh, that's an AN 96416 or AN 96516 washer. You know, over time. But it may take you 20 years. Okay? Identification, installation of aircraft materials. So composites. We use 4130. Anybody know what 4130 is used for? Aviation 4130. Memorize that number, 4130. Maybe not for now, but for landing gear class. That is what your struts are made out of. 4130. Folio struts. 4130. 4130. Chromoly steel. Chromoly bendium steel. A Snuvian. Accurate. Okay. Use of precision measuring instruments. Every year, I will have someone that says, it was the instrument you gave me. I said, that's strange, because I checked it before I gave it to you. So, it's oftentimes the way you're looking at it. So precision measuring instruments. Okay? Give me a precision measuring instrument we use in aviation.
Caliper.
A caliper. Micrometer. Tape measure. We do.
Depth gauge.
So what?
Depth gauge.
A depth gauge.
Torque wrench.
Torque wrench. Machinist scale. Right.
Gauges.
So what?
Feeler gauges.
Feeler gauges. Good. Anything else? Ball gauge. Ooh, ball gauge. There's no ball gauges. Ball gauges. Come on. It's still precision. Depends on how tight you make it. Precision. Ball gauge. Yeah.
You guys use surface roughness testers?
Yes. Or scratch depth tester. Yeah. Same thing. Yeah. All right. Determination of material suitability. Can I use 2023 instead of 2024? Can I use 2024 T2 instead of 2024 T3? Oftentimes, yes. The T determines how long it was treated or hardened after. So you can use one, sometimes you can use T3 in place of T2, but not T2 instead of place of T3. And so one of those things that, all right, where do I look for that information? Do I have to have it memorized? No. But you've got to be able to find the information where to go for it, okay? Application of safety wire, okay? I call this the blood drive of Matson Pros, okay? You're going to get well acquainted with safety wire. You're going to do it by hand. You're going to do it by safety wire pliers. You're going to do props. You're going to do bolts. Lots and lots of safety wire, okay? And that will be good for another gift card. Okay? All right, any questions so far? Fabrication and inspection of aircraft control cables. We're going to make the control cable, and it's going to have to hold, okay? Welding types and inspection, makes you a little bit of a funny critic, because you have to be able to inspect welds in this class, even though you've not welded yet. And you have to be able to look at it and say, that's a terrible weld. I can't weld, but that's a terrible weld. No, I can weld, but the point is you got to be able, in this class, before welding class, be able to look at a weld and say, from a inspection standpoint, that's terrible. You know, you don't want to hurt the person's, character, but you just say, hey, that was terrible. Because we have to determine from this class a general understanding of airworthy versus unairworthy. Okay? And then lastly, principles of aircraft inspection. We have lots of methods. Give me a method to the madness of ways you would inspect an aircraft. So what? Yeah, eddy current, good. You can do an eddy current. Wow, I already jumped into the deep one. All right. Your eyes, visual inspection. You ever looked at an airplane before? Okay, there's one method. So we have two of them. Any others? A tap test. Oh, it's one of my favorites, but it's Barb's least favorite, as everyone starts tapping over the next few weeks. Tap, 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 tap. Any others? Okay, listening. You can use your ears. Yep. Feel it. Put your hands over the exhaust. See how hot it is. Yes. Non-destructive testing. We've already had one. Eddy current. What else? What's another one?
Test individual parts.
Okay. Give me a name of a non-destructive method.
Magnetization.
Okay, good. Magnaflux. Good. Any others? Yep.
Vibe test.
Yes. Okay. All right. You could also do a what's the sound one that bounces back? No. It's in AC 4313 under inspections, section 11, towards the back, like third page over. Anyway.
You're talking about that scope thing that can check to see if there's a crack?
Yes, but it's not eddy. It's the other one. Ultrasonic. Thank you. Ultrasonic inspection. So it sends a sound wave through it. Yeah.
I doubt there's any radiography done anymore.
Good. It is actually an AC 4313 radiography. Are you looking at it?
No, I had training in it in the
Okay.
Army, but it was the last class to have training.
So they actually can still X-ray an aircraft with radiography. Yeah.
It's set up
I've
like
never seen one.
cones and, stay out of this area.
Good. You can use your fingernail. We also have a scratch depth gauge. Because your fingernail, you can't always tell how many thousandths that depth is. I said you can't always. I didn't say you can't. You can't oftentimes tell the difference between 8,000 and 9,000. But on a crankshaft, if it gets to 10, you can't grind it anymore. Okay, those of you who know what I'm talking about. In aviation, we're only allowed to grind a crankshaft 10 thousandths of an inch down. You know, in the automotive world, they will grind and grind and grind, and then we'll say, oh, we'll find bearings and make it fit. Aviation doesn't work that way. All right, any other questions, comments? All right, I want you to take a 10-minute break. Here's what I want you to do. I'm going to be super clear with you. I want you to take a 10-minute break. At 7:50, I want you to have your toolbox. I want you facing the TV screen with your toolbox, and we'll be all looking, all in this hangar out here with your toolbox, looking at TV screen. If you don't have a toolbox, get with somebody who does. Okay? Intro. If you don't get it, it's totally okay. It's just that's kind of the point of today is if you're not used to reading a micrometer, if you've never spent a lot of times reading a micrometer, it can be slightly confusing, okay? And then when we go to 10 thousandths place, it could get extra confusing, okay? And frustrating, because it's like, man, what in the world? A totally don't get what he just said, okay? What is this called? What is it called? Digital vernier caliper. Okay, you need to remember the word veneer. Why? Because it's on the FA written. Okay, that's why you really need to. But otherwise we call it a caliper. But to be snooty and correct, we'll say vernier caliper. Okay. Yes.
How do you spell veneer?
V-E-N-I-E-R, veneer caliper.
What does that mean?
I don't know. Good. You can look it up. Homework. Good. Thanks for finding that out for us. Well, it might help us. All right.
Hey, Ryan,
Yes.
does there have to be a second arm now for auto pressure?
Oh, maybe it's V-E-R-N-I-E-R. Vernier. What did I say?
You said V-E-N-I.
Vernier. V-E-R-N-I-E-R. Yep. Vernier caliper. Okay. These are what we're going to focus on for the moment. These are micrometers. Now, I have my own digital one, and because of my own sinful nature, I took it home so that I'm not doing it quickly in front of you. You have to see the old guy do it too, okay? So, when you're doing the old manual style, I'm going to do it with you. Otherwise, if I'm doing my kids' engines and stuff like that at home, I'm just using a digital one so I don't have to think, okay? It's like I can whip right through it and be done. Right? We have different scale micrometers. Now I have quite a few here. I have 6 micrometers in a case. There's lots of these cases. Okay? But we have a 1 to 2 inch. We have a 2 to 3 inch. Sorry. 1 to 2 inch, 2 to 3 inch, and 3 to 4 inch. So anything within those ranges, okay? Before you start with a micrometer, the first thing you need to do is be able to get the measurement, excuse me, for the size that you're going to be using, okay? So this is a gauge block. Gauge block. So you're going to take it, and you're not grabbing this portion here, okay? When you're going to tighten it up, you're not grabbing the big portion. You're grabbing this one right here. You hear it click? Did you hear that? Cute little click, 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 click. Okay? And then you lock it, and you can pull it out. Okay? And this will tell you can you see it? Oh, no. Ah. I am just barely off, okay? It is almost dead on 0, okay? So, you could adjust that one just a little bit, or you could retry it again just to make sure that you were perfectly on. But let's get over here and see if we can find one that's way off, just for fun's sake, and I'll show you how to adjust calibrate a micrometer. So, before you're measuring piston and everything else, you want to be able to calibrate one correctly. And then make sure it's not diagonal like this, because it will be wider than it should be. Shane, can you close that door for a minute so we can focus on math for a second? Oh, this one's pretty good off. Yeah, wow. It is significantly off. Oh, nope, it's on.
Are you comparing it to one that's calibrated?
You're using a gauge block.
Okay. Oh, is that just a permanent?
This is permanent. It even says this is 3 inches. See? Whoop, flip it around. See how it says 3 inches?
Yeah, I was thinking it was like.
So then I'm getting this in here and I'm tightening it down, and it is dead on as well. It is dead on. You see that 0? I mean, it is on. Okay. I gotta find one that's off. My students did such a good job last year. Wow. Because all of recip engines, we use these. Okay. Now, 0 to 1, you don't have to use a gauge block line. Because you close it all the way to 0. Okay.
this like calibrating the tool? I've never seen these before. So are you like
You've never seen
calibrating?
micrometers or never seen gauge blocks?
Either.
Okay,
So,
good.
I mean,
Alright, so we are making sure that our standard is correct. Sounds very biblical there, doesn't it? Okay, we wanna make sure that it is a correct starting point before we go and measure valves, or before we measure pistons. Okay, very critical before you measure a bolt, because as you'll learn in the next few days, if you get the wrong hardware, people die. Okay? Oh yeah, this one's off by just a smidge. Okay, so you got two little cute tools here. Wham. Alright. So, the way you adjust this is you have a hole here on the back. So you take the wider portion and you shove that one in the hole. Okay? And you gotta think through which direction it wants to go. So, if my zero, any ideas if we turn this on, does it get the glare off? No. Oh,
Do we turn the light off overhead? That might
don't go to sleep.
Might make it.
Don't
dark.
do it.
Well.
Alright, so you, instead of going this direction, okay, I need to take the hole and go the other direction, okay? So you lock that one in there, okay? This is the actual micrometer itself is still locked. And then I'm gonna take this guy here. Yeah. Sorry, I have to think through this too. As I told you, I have a digital one at home. So nice. Okay, so I just barely moved this one here. And I moved it towards the zero, just a smidge too much actually. Let's go back. Doesn't take much. Ooh. Oh yeah. Oh yeah. You like it? Dead on zero. Okay. So you can double check yourself again. So back it up and then come back to it. Okay, I'm still off just a little bit. Okay. I don't need to put the small one in because I don't have to move it very much at all. Okay. And so sometimes I have to do this 3 or 4 times until I get it right. Because what happens if we get our starting point wrong?
Everything you have here is wrong.
Every one of our measurements on our engine's wrong. Oh, yeah. Are you happy with that? Everybody good with that? All right, so you saw how I did that? Hey, just be patient and persistent. If you're in a hurry, you're going to mess it up. Okay? Gentle movements. You didn't see me, I'm just barely putting a little force on it just to get it to move to the direction I want. But it is on. Okay? Now, let me switch PowerPoints here. You'll be patient with me for a second.
how often do you have to calibrate the tool?
Here at SMAT, I do it every time I touch it. Because if I'm using it, and I'm using it like continuously, I'm good. But the moment I put it in the box and I let somebody else, even if it's, hey, Shane needs it for just a minute. Now, I trust Shane. But, his touch may not be my touch, okay? So when he gets over there and he tightens it up, or he leaves it locked and then he tries to tighten it up, now it's going to turn it. Got my problem? Got my issue there? So the moment he does that, boom. So it's going to throw off the calibration. Did he mean to do that? Did he catch himself? No. But what's happened is when we get to recip engines, I wish I had a quarter for every time a student said, the micrometer was on. and all my measurements are smaller than they're supposed to be. So then I go and grab a micrometer out of another box, sit down, and I calibrate it. And then I go over there and measure it, and I'll say, huh, it's within limits. No, it's not. Let me see that. Oh, I had the thing set wrong. I mean, it's been dozens upon dozens times. Okay? If the measurements are not right once or twice, don't keep doing the same thing expecting the same results. There's another name for that. Okay? Insanity, yeah. So, just a quick review here. Oh, not as high-tech today. Here we go. All right, so scales and rules. Everyone has a machinist scale, yeah?
Yeah.
All right, good. So we have 16ths and we have 8ths. Ooh, let's do a little quiz. Who's gonna pick on it? All righted. Okay, a 16th is bigger or smaller than an 8th?
16th is smaller.
Ooh, correct. Shane, a 32nd is bigger or smaller than a 16th?
It's smaller than a 16th.
Good, all right. Israel, 1/4 is bigger than an 8th. Yes. Correct, good. Swift, 7/16 is bigger than a 1/4. True, okay, good, all right. Zachary, 9/16 is smaller than a half.
False.
All right, good, good. 8/16, 9/16, good. All right. So machinist scale, know the scale. Know the scale. So the little ones, it should usually say 1/32 means each little mark is a 32nd. Your machinist scale says 1/64. It's like, you got to get out and look because now 1/64 is smaller than 1/32. So you're going to have extra tick marks there. Very, very small. The guide on the back of your machinist scale will be your lifesaver this year. Oh, flip it over, and it already does the conversion for you. Turn it around, it's like, oh, 9/16 is point, what is that? 0.5625 or something like that. Oh man, it's just over a half inch. Yes! 0.5 is half inch. So, hopefully that will be a great benefit to you. All right, I already demonstrated this, so I don't need to show you this here now. Okay, your gauge block or whatever your gauge block is, okay? Those telescoping gauges that I showed you in the top drawer of the toolbox, that's what I'm using a micrometer. So I'll take the measurement, wham, and then I'll bring it over to the micrometer, and then I'll use this little bitty portion right here, to turn it onto that telescoping gauges until it clicks. And then stop. Lock it and then read it. And that's the measurement for that telescoping gauge, yes.
Is there a time when you would have to use this C version of the measuring device, great with names, opposed to the veneer caliper?
Good. Which one is the most accurate? Micrometer. So this is a precision tool. Vernier caliper is not a precision tool.
Okay.
And that is actually a written question. Which one is the most precise? It's not precise. I can't remember what the written question is. You guys are supposed to be studying prepware. I can't think of the word, but it's like, which one is a precision tool for measuring engine parts? And it would be the micrometer. Okay? So this is going to be the most precise. Now, if you're doing bolts and nuts, man, bam! I'm going to pull them out, measure them with a vernier caliper about as quick as I can.
What makes that more precise?
Because this one actually goes to 10,000ths. Vernier caliper usually only goes to hundredths. Sometimes it goes to thousandths. So 4 zeros. Tenths, hundredths, thousandths, 10,000ths.
And that goes to 10,000.
And this one is a fine tuning.
audits?
Yes.
The clicking sound, does it continue to advance with every click, or is it like a torque wrench where it's actually stopping?
It's stopping. Yeah, but if you nudge the end right here, the bigger part, it will turn, okay? And for those of you who may not have as much finesse as others, please don't turn that barrel. It will turn inside, okay? I have one that's been victimized. It no longer has the end here, okay? Yes?
Are you allowed to turn the barrel like at all? Is it
Yes,
like a
if you're needing to
course
make
and fine?
big movements like this, big movements, fine. Okay, but then when you get the part in there, or whatever you're trying to measure, you just, till it clicks, okay?
So you're saying if it tightens onto the thing, you continue to turn the big barrel, then it'll
Well,
move
yeah,
inside.
and the thing that's annoying is when you're doing the big barrel part here, the main barrel, if you're doing that on a telescoping gauge, the telescoping gauge has a spring in it. And you wonder why the springs don't pop out anymore, because somebody's going, not clicking, because you're not doing it correctly. Okay? All right, I'm venting, sorry. All right, so measurements. We have the parts of it. You have the barrel, you have the ratchet stop, you have the main thimble. I kept calling barrel, but this is the actual barrel. Thimble part here, or adjusting thimble, okay? And then the measuring face, spindle, and anvil at the end, okay? You're not gonna be quizzed on parts of the micrometer, no.
So, I was just not thinking, so you know how when you said like, for like, you don't have that feeler gauge for like the 1 to 2 inch one, because you can just move it all the way to the end? Why couldn't you with the 3 and 4, since it still has that gap, just move it all the way until it stops? You know what I'm saying?
But
So like,
what's gonna be set at 3 inch then? How do you know that the barrel's set at 3 inches perfectly? It's not touching each other, see? There it is, right there. That's one's all the way down to the very end. But who says that barrel's set at 3 inches?
Oh, yeah, I see, okay, I see.
So I gotta grab a 3 incher, shove it in there and say, yep, that's it.
Okay, I see, okay, I see.
Okay. All right, let me start off with playground numbers first. Everyone ready? Everybody take a deep breath. Here we go. All right, playground numbers first. So we have easy peasy. Here we go. All right, so we have 0.1, 0.2. Everybody good there so far?
Yep.
All right, you know that we had to put the string on here for me. Okay. All right, so a micrometer will have, if it's a 2 to 3, so if the micrometer says 2 to 3, then the 2 to 3 is the first thing that goes on it. So you then put 2 dot, what? Whatever the next thing is. So we go 0.1, so this is 0.1. So say our measurement comes in right here. Okay? When we're getting there, this bad boy comes all the way over here and says, boom, I'm stopping right there. Okay? We get our little click. Click. And it clicks right here. Everybody good? Everybody with me? Okay? So if it's a 2 to 3 inch, right here, bam, 2 to 3 inch. So I'm measuring it, and I get it 2 to, so the first number I need, because can it be 0? No, it's a 2 to 3 inch. So the first measurement is going to be 2 to 3 inch. So I'm going to turn that bad boy, click, and it comes all the way over here, and so I put 2 down. The next number that I need is 1. So I'm going to come over here and put 1. Okay, the next thing here is 25, 50, 75. 1. So 100, okay? 1. And then we go 25, 50, 75. But did I get all the way to 50? No. So then I came over here next right here, okay? So I know it's 25 plus whatever the number will be here. So if it's 25, and then I get to, sometimes it'll say 10, okay? It'll say 10, and then 9, and then 8, okay? Whatever. But say the mark lines up right at 10 here, okay? then what you're gonna do is, you're gonna say in your head, in your smartest way, you're gonna say, it's 25 plus 10. Because is it 25? Yeah, it's past 25. Is it all the way to 50? No. But it's 25 plus 10. Anybody do that math? 25 plus 10? 35. So then that 35 goes here. Okay? I only did 3 places. Everybody good? I didn't do 4 yet. Everybody good with 3 places? Okay, let's do another one. All right. This time, our micrometer is a uno to dos. Number 1 to 2, okay? 1 to 2, all right? 1 to 2 micrometer. Mr. White, David White. What's the first number we need to write down?
1.
Boom, nailed it. Okay. Clayton.
Yep.
What's the next number we need to write down, sir?
0.
0. Why?
Because we've not reached 21 inches yet.
Nailed it. We're not to the 1. So you automatically know what the second number is. If we were out here, it would be 2. But we didn't reach 1, so we know what the next number is. All right. Mr. Jedediah.
8.
What's the next number that we need to write down? Or gently work me to it.
8. So you're at 75 there, and then you look over the
So
right,
25, 50, 75.
and then you go to the dial and add that number.
Add this number to what?
75.
So we have 0.075 plus what?
The 005.
005. Because there's your 5. Bam! Comes down here. And we get what?
80.
80.
Or 8.
So micrometer was a 1 to 2. So if you forget the first number, that's oftentimes really frustrating. This number right here at the bottom, 1 to 2 or 3 to, this is 3, 4. Okay? So then we add that number. Everybody good with just the first 3? We're not going to go to 4 yet. Everybody good with the first 3? So tenths, hundredths, thousandths. Yes, sir.
Is the dash 6, 5, and 4, are those the thousands, or how are we using them?
Yes, these are the thousandths. What you're adding to this, so tenths, hundredths, thousandths. So you're adding these thousandths, and it goes all the way to 24. Ooh, let's make it. Hold on, don't say another word. Let's make it. Let's make it a little fun, okay? I got time. I got time. I got time. Because I need you to get this to save me later. If you get it this week, we'll be good to go. Okay? All right, so we're going to do one right here. We're going to come over here and we're going to put okay, and then we're going to put this, and then we're going to do, James, let's do a Continental engine. So we'll do a 5 to 6 scale piston. Oh, let's do Lycoming. Okay, because we'd have to go over 2. Continental pistons are bigger. So we'll go Lycoming, a little bit smaller. Okay, so Continental piston, 5 to 6 inch scale. Okay. So our first number should be, hold on, shh, don't say. Mr. Randall, what's our first number? 5. Why? 5 to 6 inch scale. That is, if you're wondering what that looks like, That's the one that will do the size of my head here. I mean, it's huge, okay? That is this one here, okay? I don't pass these around because we use them, okay? All right, so 5 to 6 inch scale. Christian, Reisman?
Yes, sir.
Okay. What's the next number we need to take into account?
1.
1. Why?
Because we passed 1 click on from 0 to 1, so now we're 1 to 2.
Well, why not? Okay, all right, I'll do it.
It's not quite at 2 yet.
No, it's yeah.
You're
It's at
right.
1.
You're right. I'm just
All right.
All right. Second guessing. Hey, dude, if I can make you confident, I will. All right, so Corbin, what's the next thing, buddy?
Is it 98 or
Where did you come up with that?
is it 98? Okay. Well, it's the 75,
Okay, so you got 75.
and then plus the 23 where it's at. Sorry, I should say it how it is. 75.
Whatever.
Yeah.
That's 75 thousandths, but what else?
And then you add those two. And hopefully that's right.
Everybody got it? All right, so what is our number then?
098.
Oh, not 0.
98, sorry.
That's right, because we already had a 1. Got it? Everybody good? Hey, did I scare you? Don't be scared. Okay. All right. All right. So, 0 inches. Everybody good there? Telling you, it helps me out the rest of the week and the rest of the year if we just take baby steps now. If you don't have it, ask. Ask, ask, ask. We'll work through it. Okay? Okay? Point 001 on the thimble and barrel there. There. Okay? All right, now we're at 1, 2, 5. But wait a second, I can't see the 2, 5. But you have a space here. Man, that's not fair. Doesn't matter if it's fair or not. It goes all the way around. It's not right up against here. So now it's 25. Remember, it starts over at 25. Okay? Got that? One, 8, 7. So 12, 75 plus 12, 87. Good? Oh. Wait a second. They just used a vernier micrometer. What is that all about? I thought it was a vernier caliper. Yes, yes. Okay, so when they're adding this, they're going to add a extra scale here. Okay? This is 10,000 scale. Now, how does this work? Hold it. Yeah, just hold on. Okay, so let's start off simple. All right, so we know our scale is 0 to 1 because they gave it to you, 0 to 1. So we got a 0, well, bam, right there, okay? And then they gave you the answer, which is nice, but we come over, it's 25, 50, 75. But the first number is this one. Got it? That's where this guy comes from. He comes down and hangs out right here. Okay, he's a 10th. But we need a 100 scale. 25, 50, 75. Is it more than 75? You betcha. So, is it 21? No. So, 75 plus 20. 95. Whoa, scared me today. All right, so it's 95. So 95 is from this 75 plus 20. That's where I came from. Got it? Yes, Shane?
How do we know it's 20? Where's the 20 lining up with?
Right below the line here.
So once it meets the line?
Yes, 21 is not to the line.
Okay, so the fourth, okay, so when the two lines meet together, that's when you know
but they don't meet. We're past the 20, but not to 21. So did we reach 20? Yes. Did we reach 21? No. Because we're turning it, and then all of a sudden we're at 20. We got 20, okay? So 20 comes down here. Now, we're going places. Are you ready, Shay?
Yes, sir.
We're going places. Okay. So now, how do we use the fourth scale? Ava, are you with me? Okay, good. Need you here. All right, how do we use the fourth scale? So how do we come up with this last number is you walk up the ladder until it comes across. So the closest one here is the 1, it lines up. But wait a second, that's where you bring this number and it comes down. I'm going to use that same scale. So 20 is past the line. I'm not going to draw on here, I want to though. So the 20 is right here. Bam, right there. You got it?
Is that because it's not lined up, you go up to the 10,000s? Is that the 10,000s right there?
Yes, so the 10,000 scale is you're going to line, which one lines up?
Correct.
Does 0 line up? No. Does 1 line up? No. Does 2 line up? No. Does 3 line up? Nope. Does 4? You betcha. So then you bring that 4 down here. Don't bring this one. You're already done with that scale. Once you've got the 3 digits, you're going to use this scale for the fourth.
So, okay, so when you've got the thousands,
Yep,
you then walk up the ladder until a line.
that's
lines
right.
up,
Till it lines up.
And then, and that line, you put it in the 10,000s.
Any, let's say it was bang on 20, so 2950. That line that's 22 is going to meet up with the 0? The 0
Well,
on
sure,
the-
it would be dead on here. And you'll see it. So if it was bang on right here, 0 or whatever, or 90, then the 0 here would line up with one of these, not with this. Because you're
Yeah.
using this scale for the fourth.
Yeah. Okay.
Yep. So this is the last number. Hey, if you see this, how do you know that? Oh, I'm glad you asked. I'm glad you asked. This scale says 3 to 4 inch. That's my first number. So this, where's my pen? All right, whatever. So this number right here comes down to here. But notice what scale it says. 0, 0, 0, 1. So it goes to how many numbers here? 10 thousandths. And there you go. Look at that. There it is. Okay? All right, let's be a little fun here, okay? All right, you see how nine, oh, you can't see, but I see. See how 9 lines up there? Isn't that beautiful?
Ryan, you might try to turn the lights back on, but turn the projector light off. I think that's for the glare source.
Flashback.
If you put a shade over it, it'll reduce.
Perfect, that's better, perfect.
Okay.
Whatever. All right. I came prepared. All right. For your thorough enjoyment, please don't say this answer out loud. Ooh, 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 ooh. Shh. Try not to give away all the answers here. Shh. Okay. Can you see what I see? Now, I haven't given you the scale yet. Without consulting me or anyone out loud, I would like for you to figure out what this is. And the scale that we'll be using is 4 to 5 inch. 4 to 5 inch. 4 to 5 inch. Can everyone see it or no? Ooh. I was trying to figure out where my pen is so I can write down the answer. Nope, I already have a victim picked out.
Who's the victim?
Are you guys ready? All right, Job, come on down.
We're gonna find out. Price is right.
All right, we're gonna give you a black one to write with. There you go. Tell us what the answer is. I want you guys to.
Alright, so we're gonna start with a 4, taken from here. And then we're gonna start with a 5, taken from here. And then we're gonna start with a 2, 3, taken from here. So we will add 2, 3 to this. And then we're gonna come up here and see that this 5 line lines up, so we'll add 0, 0, 5, which equals 7, 3, 5.
All right, thank you so much. Hand me that one. All right.
What? Oh, Joe. Sorry.
Tiki, come on down. Is he right or wrong? You need to fix it or do something.
I had a 0.
Come on down, I said.
I don't know what you're saying.
But you cannot erase his. You have to write your own on the other side of the board, please. I don't know. Let's see. I do know, but let's see.
Well, we're not to the 1. So that's the 4. You're the 22, it's a 23. But which place was it? This is supposed to have 4 digits in it. And I don't know where the 4th digit is found.
Okay.
I know there's a 4, I know there's a 7, because that plus the 50 was the 73, and the 5 lines up, but I don't know where to get the 4th number, and I'm pretty sure this place is the number that I'm missing.
Okay.
But I would say 735 is right,
All right. Thank you.
but I just don't know where to get that one.
Okay. Thanks so much. James, would you change anything about that?
Maybe.
Which one, sir?
So,
Wouldn't it be 2, 4? Oh, wait, no. Yeah, I just, sorry, I can't see it from right now. I thought there was a 4 and a 5.
No problem.
But I agree.
Problem. You agree with who?
Joe, Mr. Milk.
Don't do it. Don't do it.
And he is incorrect. Tiki, you are correct.
Can you explain how?
I would love to do that. That is my job. Okay, so the first range is 4 to 5. So you know it's automatically a free given? 4. The second freebie is what the first place is. The 10th. Did you reach the 1 over here? No. So you got to bring the 10th, this 10th over. Bam! There it is. You're not happy about that? 73, yeah, yeah? You had all this perfect. You had this perfect, dude. Nailed it. You just forgot your tenth.
Cracked under pressure.
Correct. So if you see this vernier side over here, scale, you know you've got to go 4 deep. You only went 3 deep. If you don't see this, then you're going 3 deep. Got it? All right. Let's make it a little easier, huh?
Easier.
Okay, I'll give you a difficult one. All right. Wait, you can't see that. Ugh. Oh, I didn't tell you the scale. Forgive me. I did not tell you the scale. Let me give you the scale. Is 0 to 1. 0 to 1 scale. All right, I gotta write my number down there too. All right. Best candidate. Come on, get 2 people here. Mr. Matthew, come on down. Oh wait, you can't write on that one. Don't write on the board. Where my rag go? You go. Hold that. All right. Show us. Sir.
All right, we said it's a 0 to 1 scale, so our first number is 0. Then it's past the 2, so the second number is 2. It's past the 5, but it's not 6 yet, so we have 5 at least. Or sorry, that's not right. It's past the half. 0, 25, 50, so we have 5 at least. Then it's here past the 5, but not to the 6 yet, so our next one is also 5. Just add it. And then the one that goes straight across is 8. So there's our number.
Okay, all right, good job. Amanda, would you change anything about that? Okay, why not? Okay, that is correct. So he kind of did long form, so just as I would say is 25, 50, and then 50 plus 5. Good. Okay, 50 plus 5, boom. 55 with the last scale coming across to 8. Any questions there?
How do you know it's a 0, not a 1 on the 1 to 2 scale?
Ooh, because 0 to 1 was a scale, correct?
Correct.
Yeah.
So did we reach 1?
Well, there's a 1 right there. So what 1?
Sure, what 1 is this then?
The 10th place. But where's the 1's place?
Ooh, I know. It's right here in front of me, isn't it? Yes, it is right here. Look. There's our little scale. Oh, let me bring it out here. Can you see it better up here? Do you see the top there, 0 to 1? So will it ever reach 1 on this micrometer? It might reach 1, but if it's down here in the lowest portion of it, it's not reached 1. You're talking about with 1 would be, look at this. Can you see how wide it would be to get to 1?
Okay, so you can
You're
tell
almost
it's-
all the way out before you get to 1. There But you're way past 2, you're definitely way past 5, you're definitely way past 8 and 9. See that? But where are we at on this scale? Where are you at right here? You barely have 2 showing right here. So if we're between 0 and 1, then we know we're only 0.2 past the 0. Make sense?
Yeah. that makes
All right,
sense.
you guys, that's it for today. Enough of your brain exercises. I'm going to give you about 2.5 minutes until devotion time to collect your thoughts and sanity. And if you need to study for your final, Joe, please do so. I saw your computer. I'm always watching.